Today's tutorial is all about double integrals. Now, there are lots of videos that I've posted on the simpler problems associated with these. So I reckon there's at least half a dozen problems from this problem set that I've posted online. Okay, so I'm not going to do the basic problems today. I'm going to do more of the challenging ones. And I'm using the document camera because you simply just can't fit an entire solution on this board for these kinds of problems. Okay, so if I have a document camera, I can just take another piece of paper. So it's simpler. And as you can see from the question, 72 involves a centroid of a region. So who can tell me what's a centroid of a region? What is it? Yeah, centre of mass, but I guess it's a two-dimensional region, so it probably doesn't have any mass. So you're right. Centre of area. This is how I would say it, right? So yeah, but when you're doing the calculations, when you're using the formulae to calculate the centroid, you are using the centre of mass type representations, right? So the tricky thing with some of these problems is actually drawing the regions. That's the hardest, the geometry is the hard part of these problems. So we're going to sketch the region of integration and set up our integrals and then evaluate them. Okay? So 72, find the centroid of the region in the first quadrant bounded by the x-axis, the parabola y squared equals 2x, and the line x plus y equals 4. So anyone done this question? Anyone? Anyone? Yes, have you done it? Yeah? How did you find it? Yeah? No problem? Okay. Maybe you can help us step through it at some point. Okay, so all right. So the curves that bound our region, let's call it D, are the following. All right, we've got the x-axis, which is just the line y equals 0. We've got the following a parabola, y squared equals 2x, and we've got the line x plus y equals 4, and all our points of interest are in the first quadrant, so I guess we should probably mention this as well. So what I'm going to do is draw in these curves and see what happens. Basically sketch our region, okay? So if I draw in the curve, say, y squared equals 2x, it's going to look something like this. Okay, I'm not too concerned with what happens down here because my interest is in up here. And if I draw in the line, say, y equals 4 minus x, then I'm going to, say, cut at 4. And I get something like that. So this is the curve, say, y squared equals 2x, or x equals y squared on 2. And this is the curve y equals 4 minus x, or just x equals 4 minus y. Okay, so where's our region of integration going to be? Or our region of interest, I guess. It's going to be in here. Now, if we're going to integrate over this region, I guess we need to know a few of the points of intersection here, right? So I can find the x-intercept. It's going to be something like 4. And these curves are going to intersect. I guess we're interested in sort of, the x and y components. So let's work that out first. Okay, so basically just put one into the other. I'm going to eliminate the x because actually the y point's what we're interested in here. So I'm just going to eliminate x from both equations, and I'm going to get something like this. So I can take y squared on 2 and equals x, and x equals 4 minus y. So if I rearrange that, I'm going to get a quadratic. Oh, 8 equals 0. Now I can factorise this. What am I going to get? Y plus 4 and y minus 2. So the line crosses the parabola twice, but we're only interested in the positive value for y here. So we can ignore the case y equals minus 2. So that is going to be 2 there. Now I could go and calculate the corresponding x point for y equals 2. I don't really need it. Okay, I don't really need it. Okay. All right, so the first question is, if we're going to use double integrals to find the centroid of D, first of all, we need to mathematically describe D in terms of the bounding curves or the bounding regions. So, essentially what you need to describe these things mathematically is 2 parallel lines and 2 maybe non-parallel lines. Okay? So what I usually do is, I either draw a horizontal line or a vertical line. Right? I'm going to draw a horizontal line in this case because it's easier. Now, where does this horizontal line enter our region D? Well, it enters at the line x equals y squared on 2. And it moves across, and then it exits the region D at the line x equals 4 minus y. So let's describe D. Okay, so I've got a horizontal line there. That's going to sort of give me my x values. So I know that this line enters the region at x equals y squared on 2. So it's got to be greater than to the right, or greater than or equal to y squared on 2. And it leaves at x equals 4 minus y. So it's got to be less than or equal to 4 minus y. Now, the second part is, okay, let's say I've got this horizontal line. How far up and down the y-axis do I have to move it to cover the entire shaded region? So if I want to move this green line up and down, what interval do I need to slide it between to cover the entire region D? Well, it's just this interval here. If I slide my green line up and down between 0 and 2, I'll cover the entire shaded region. Okay? So y is between 0 and 2. Now that's one way of describing the region. There are other ways, and you may have your own methods, but that's one way of doing it. You may not want to use these horizontal lines or vertical lines. You want to use some other method. That's okay. As long as it works, I'm happy with you to use your own methods. This is just one method that will work pretty much every time. Okay, so what is the formulae for the centroid of a region? Well, centroid of D is just the following. It's just the point which we usually write x bar, y bar, or you may have your own notation, with the following. X bar is just the first moment, x. The first moment about the y-axis divided by the area of D. Okay, so the top here is just the first moment about the y-axis. The density is constant, of course. And similarly, the y component is just the following. Okay, so these are the formulae that you would have seen for centre of mass, but you can assume that in these cases, the density function, which usually is sort of multiplying in here and here and in here and here, the density function is just 1 or constant. Okay, just one's easier. Okay, so these are the things we have to work out. First of all, we have to work out the area of our region. Then we have to work out these two double integrals. Then just put them together. Okay, so let's just make a little note here. These formulae are similar to centre of mass of just with the density function equal to 1. Okay. All right, so let's actually do some integration. Firstly, let's find the area. We've got our region of integration, so we can set up our double integral, no problem. So let's do it. Okay, so we spent the time writing this thing out mathematically. Let's actually put these into our limits of integration. So these will be the outside limits of integration. These will be the inside limits of integration. Okay? So it's just the following. So I've got those. And y squared on 2. And dA, remember, is just, in this case, dx dy. Now, why have I got the dx and the dy's around that way and not the other way? Well, you can get it from your description here. You see x is between this function and this function. So these things have to be paired up with the dx. Okay? Y is between 0 and 2. So the outside differential has to be paired up with the outside integral sign. So these double integrals, these repeated integrals in this case, very easy to evaluate. You just do the inside integral first, and then move on to the outside integral. So imagine you're integrating 1 with respect to x and holding everything else constant. Okay, if there's y's there, you just hold them, imagine they're constant. So when I integrate 1, I'm going to get an x, right? And then I'm going to sub in this top limit of integration and take away the bottom limit of integration. So if I integrate this, I get x, plug in 4 minus y, and take away y squared on 2. Okay? If you want to put an extra line in there, you can. Okay, maybe I'll just put an extra line in there just so everybody's clear. Okay, so I've found the antiderivative, then I just sub in that and take away that when I sub it in. So now in the bottom line, I have a single integral, the integrals that we know and love. I can easily integrate each of these things term by term, right? So I'm going to integrate this to get 4y, this to get minus a half y squared, and similarly with this one. Oh, yeah, 6. So it should be 6, right? Thank you. Thank you. Okay, so now it's just the normal evaluation rules. We should put in our y equals 2, our y equals 0. The second term is going to give 0, right? So just a little bit of algebra, hopefully. So I'm going to get 8 minus 4 on 2 minus 8 on 6 minus 0. So I'm going to get 6 minus 4 on 3, which is going to be 14 on 3, according to my calcs. Okay, so that's the area. That's the area. So we've now got this component and this component. We still have to do 2 of these double integrals though. Okay? So let's do it. Let's do this one up here. Okay, so we will just set up the integral the same way. We've just changed the 1 here to an x. Okay, the integrand's a little bit different. The thing we're integrating is just a little slightly different. So the limits of integration are still the same. We do the inside integral first, and then we move on to the outside integral. Okay? So that x is going to, I'm integrating with respect to x, so that'll become a half x squared, and then I just sub in my limits of integration for x. So I can take that half out the front. When I sub in that, I'm going to get 4 minus y all squared, and I'm going to get y to the 4th on 4 dy. Now, it's tempting to expand this bracket. I'm not going to do it. You can integrate that straight away. You'll get a power 3, and you've just got to sort of divide by negative 1/3. Divide by negative 3, sorry. So this is going to be something like this. And to take care of business, I just need to multiply by negative 1/3. And over here, I'm going to get this. That looks good. So now, all I need to do is sub in y equals 2 and y equals 0 and simplify, hopefully, with my algebra. Okay, so I'm going to get negative 8 on 3 minus 32 on 20 minus 4 to the 3, that's, what's that? 64. Something like this. Okay, so if you simplify those fractions, again, according to my calcs, you'll get 128 on 15. All right, so let's actually calculate our first x component for the centre of mass. It's just this divided by the area. Okay, we've got both of those now, so we can do it. Okay, so it's 128 on 15 all over 14 on 3. So you just invert. And what are you going to get? 64 on 35. Hey, happy, we've done something. Okay, that's only 1/2 of the 2 components that you need. You've got the x component for, now we need the y component. So let's go through and calculate the y component. Okay. So, all right, so to get the y component, we need to get this up here first. We've got that, so let's just do this integral and then we'll be finished. All right, so my region of integration is still the same. I'm just integrating y this time. Okay, so as you would expect, do the inside integral first, and then move on to the outside integral. Sorry? No. No. Sometimes if there's symmetry in the region, you can get, you can use that to your advantage to get the same x bar and y bar. So if there's symmetry, say, about the line y equals x, and there's constant density, you can use symmetry, things like that. Okay, so integrate with respect to x. So we hold y fixed, just measures the constant, and we're going to get xy when we do this first integration. Okay, so let's put those in, replace x with the following. I'm going to get something like this, 4 minus y. That's the first one, then I plug in that. I'm going to get y cubed onto dy. So I am going to expand that bracket and then do the last integral. So I'm going to get 4y minus y squared minus y cubed on 2. So let's just integrate this term by term. What's that going to go to? 8. And now all I need to do is plug in y equals 2 and y equals 0 and simplify. So I'm going to get something like 8 minus 8 on 3 minus 16 on 8, which is just 2 minus 0. Okay, so I'm going to get 6 minus 8 on 3, which is just 10 on 3. Okay, so finally, we can find our y coordinate for our centroid, or our centre of area. It's going to be this divided by the area. So the area was 14 on 3. So the 3 is going to cancel, and I'm going to be left with 5 on 7. So, our centroid is 64 on 35, 5 on 7. Okay? Now, can you see why I didn't do that on the board? I would have had to have filled about 3 or 4 boards with all that work. Okay? Questions? Unlikely you'd get something like that in a class test. Final exam, who knows? One of the great weapons for doing these kinds of problems is symmetry. Okay? So you might have a region that's symmetric about the line y equals x. Well, you know that the centroid has to lie on that line. Okay? You know that centroids have to lie on the line, and centre of mass too in some cases.